Okay, so this is continuation of the last video that we had on about quadratic graphs of quadratic functions. So the this part was the one way of graphing quadratic functions, right? So now let's proceed to another way of graphing quadratic function. So we'll let you decide which one you would like to use in graphing the quadratic function or in identifying the vertex of the quadratic function. By the way, the vertex in this quadratic function is, you notice this one is 0, 2, the lowest point, remember, which is the minimum point. Then the axis of symmetry is the y-axis, right? This one. And then the minimum value, okay, since we have the minimum point, so this is our vertex. At the same time, it's the minimum point. And the minimum value, it refers to the y value in the vertex. So y value here is 2. Okay, but the minimum point is 0, 2. Same with the vertex. The minimum value is referring to the y value here in the minimum point, which is 2. Right? Now let's check the domain. So in a quadratic function, the domain is always all real numbers, all reals, okay? Lahat ng real numbers sa domain. But sa range niyan, usually, I think most of the time, it has a limit. So how do we get the range? So the range here states that y is greater than or equal to 2. Meaning to say, if the graph faces upwards, it says that the numbers goes up, right? It goes up. So from 2, since 2 is included, that is why we have an equal symbol. From 2, and then it goes on and on until infinity. So that is why y is greater than or equal to 2. Okay? But if the graph faces downwards like this, for example, okay? So meaning to say, it's less than, okay? The range is less than or equal to 2. In this case, it's facing upwards, so it's greater than or equal to 2. Okay, now let's proceed to graphing a quadratic function, a parabola in standard form. So first is you have to find the axis of symmetry and find the vertex. So to get the vertex, remember, we have to solve for it, just like what we did earlier. You can use the formula or you can just substitute the x. Then find two other points and reflect them using the concept of axis of symmetry. Then connect the 5 points using smooth curve. So first, for the axis of symmetry, you need to make a table. So let's go with step 1. So step 1, find the axis of symmetry. So to get the axis of symmetry, you need to solve it, of course. A is equal to 2 and B is equal to negative 4. So to put it simply, why is it positive 4 na? Since we have negative times negative, so it's positive 4. Then 2 times 2 is 4, so 4 divided by 4, it's 1. So that is your axis of symmetry, alright? Axis of symmetry, so that's your axis of symmetry. X equal to 1. Step 2 is we find the vertex. Since we have already the axis of symmetry or the x value in the vertex, we have to find the y. So how do we find the y? We substitute the x here, this one, the axis of symmetry, the value of axis of symmetry, 1 to the function. So that becomes 2 quantity 1 square minus 4 times quantity 1 minus 1. So 1 square is basically 1, right? Okay, so 2 times 1, that's basically 2, and then 4 times 1 also, that's 4, so 2 minus 4, then minus 1, that's basically, alright, so negative 3. So now you have the vertex 1, negative 3, which is located here. So by the way, this is our Cartesian plane, so this is our origin, this one here, the highlighted one. And this is our axis of symmetry. To locate the 1, -3, the vertex is 1, -3, so it's 1, positive x. And then -3, it's here, so here's the point, vertex. Now you have the vertex, you do the third step, find 2 other points. So in finding the 2 other points, you can just actually choose any value on x. Usually I use the positive. So in this case, we're going to use 2 and 3, alright? So to solve, how do we get the y? Simply substitute it here. So for y is x is equal to 2, y is equal to 2 square. So this is actually 8 minus 4 times 2. That's 8. So 0. 8 minus 8 is 0. Then minus 1, -1. And then -1. So for x equal to 3, let's locate this first. 2, -1, it's 2. This one, and then -1. There. And then for number 3, x is equal to 3. 3 square. 3 square is 9 times 2. That's 18. Minus 4 times 3, which is 12. So 18 minus 12. How much is that? 18 minus 12. That's 6, right? 6 minus 1, that's 5. So for this, 3, your y is 5. So 3, where's that? 3, positive 5. 1, 2, 3, 4, 5. So it's here, right? Now you connect these dots using a smooth curve, right? Smooth curve. Before you connect that one, you reflect these points first. How do we reflect these points? So we can actually reflect those points across the axis of symmetry by counting the distance of these points from the axis of symmetry. So for example, this one, if I count the distance of this point from the axis of symmetry, which is here, so that is 1, right? 1 unit. So if I locate that on the other side, I will count also 1 unit to the left. So it's here. And this one, 1, 2. So I'm going to count also 2 units. 1, 2. These are the points, the reflection of these points. So if you're going to connect that using a smooth curve, this will be the image. These are the points. And then let's connect. Then that's it. That's the graph already. Now you have the graph of the quadratic function to y equal to 2x squared minus 4x minus 1. Alright? So if you have any questions, you can actually comment down below in the comment section. Thank you and God bless.